and the session is now recording.
Okay, well, welcome everybody. My name is Ken Smith. I'm the Systemwide Laboratory Safety Manager for the University of California. And it is a great pleasure that I'm here today with Dr. Bob Emery, who is joining us here from the University of Texas Health Sciences Campus, Houston. And it's going to be talking about chemical safety committees and their importance and their role in the academic environment. For those of you that aren't familiar with Dr. Emery's work, he is I would be very concise to say, a world-renowned expert on health and safety matters, in particular as they relate to the academic safety culture there for it. And so it is a pleasure to have you here today, and we look forward to your talk. So.
All right, thank you. We're going to get the presentation queued up, and greetings from beautiful Houston, Texas. I hope that the weather is as nice out in California as it is in Houston right now. So we'll see if we can bring up the first slide. All right, perfect. All right, thank you. So what I'd like to talk about today are really two items. One having to do with this issue of a chemical safety committee that we have here at the Health Science Center, which we feel has reached a balance between providing some level of institutional assurance for the work with certain chemicals. And then I'd like to kind of weave that into this larger issue of safety culture. So we're going to talk about the essential nature of chemicals as they are related to research and teaching, the key missions of the university. Talk about the development of our chemical safety program in this committee, and dwell into a little bit about this issue of the balance achieved between supporting science and ensuring safety. And then we'll provide some comments about safety culture, and then certainly we'll entertain your questions. We'll welcome any feedback that you might have. Before we go on, I would like to express my appreciation to the Southwest Center for Occupational and Environmental Health continuing education program. This is one of the NIOSH-sponsored education and research centers. Happens to be located here in Houston, but services Texas and the surrounding states. It's located here at the University of Texas School of Public Health. Dr. Janelle Rios is the CE director, and she's been kind enough to accommodate setting up this webinar. And she said if anything goes wrong, I can blame it on her. So I certainly thank her for supporting and co-sponsoring this educational event. I think I'm preaching to the choir when I say that research would not be possible without the use of chemicals. And in some sort of form or fashion, all of these chemicals can be potentially hazardous, as noted by Paracelsus as far back in the 16th century. To protect individuals working around chemicals, there's these typical things that may be present where the issue of hazard communication, where we're making individuals aware of the chemicals that they're working with and the hazards that are present and how they might protect themselves. It's also reflected by something referred to as lab standard, and then we also have these documents called material safety data sheets. And so these are the general things that are in place to afford some level of safety for individuals working in the lab. But what we were particularly interested in here at the Health Science Center was, what about work with particularly toxic or dangerous chemicals? What we were wondering is that could we develop a system where oversight could be provided for this subset of particularly toxic and dangerous chemicals without grinding the larger mission to a halt. And that's where I think the art and science comes in, is that you've got these teaching, research, and service missions for the university. And if we were reviewing all of these chemical uses, it would be bureaucratically too burdensome. And other such systems exist within the university environment. I think many people are familiar with the systems that exist for radioactive materials, where if someone's going to be using a very small amount that's referred to as generally licensed, those sorts of uses are typically not reviewed, but licensed radioactive material is, and is typically reviewed by a radiation safety committee. Likewise, those individuals who work with recombinant DNA, if they're working with exempt strains, commonly referred to as 3F, they're not reviewed, but non-exempt strains are reviewed by an institutional biosafety committee. So we felt as though a model existed that perhaps we could use to assist us in creating a program that provides some level of oversight for chemical usage as well. What we were really trying to do here was strike a balance, and it was critically important that we had active faculty involvement on this, because chemical use is so ubiquitous in research. If we reviewed all chemical usage, it would grind the place to a halt. Imagine if we had a requirement where we were to review every flammable material that was used at the university. So the ultimate goal was to reach concurrence on a subset of chemicals by either name or characteristic, that a peer group of experts felt would benefit from some level of oversight with regard to safety aspects. Just to give you a little feedback on the University of Texas Health Science Center at Houston, we are one of 15 component institutions of the University of Texas system. We're largely a graduate program, although we do have some undergraduate programs, but by and large we're graduate medical school, school of public health, school of dentistry, and the like. We have about 4,500 students and about an equal number of faculty and staff. To give you a sense of the size, about 4 million net assignable square feet, about 1,600 research labs, and last year about 240 million in extramural research expenditures. So perhaps that allows you unclear, does that relate to infectious disease, does it relate to hazardous chemicals and the like. So what I did was work on separating out and redefining these committees. So today what we have is a radiation safety committee. We also have a biological safety committee, which covers not only the role of the institutional biosafety committee for recombinant DNA activities, but also covers any other work that may involve potentially infectious microorganisms. So, for example, we do work with multiple drug-resistant tuberculosis. We do work with other sorts of agents. So all of that would fall under the purview of the Biological Safety Committee. And then we sorted out or teased out the chemical-related health and safety aspects and created a Chemical Safety Committee. And I want to be clear that as of today, this is not a regulatorily required committee. In the case of Radiation Safety Committee, that's typically required if an individual possesses what's called a broad license for radioactive materials, and there are requirements for an institutional biosafety committee if you're working with non-exempt strains of recombinant DNA. But there is no requirement that I'm aware of that requires a chemical safety committee, but we felt, and the institution felt, that it was best practice to have an entity largely populated by faculty that would provide some oversight to the use of some particularly hazardous chemicals. All of those committees are now under an overarching group called the Safety Council, and the Safety Council not only gets regular reports from these committees, the research-related committees, but it also addresses these other things that might fall in, for example, the hazards crossing the street and on and on and on. So the Safety Council essentially addresses any health and safety concerns, including security concerns that might be present on campus. And represented on the membership are the chairs of these subset research-related committees as well. So the charge of the Chemical Safety Committee is to report to the Executive Vice President for Academic and Research Affairs on matters related to use of chemicals that may be hazardous in either clinical research or educational activities. And we have some definition there of what hazardous chemicals are, but unfortunately those are pretty broad. And so what we're really interested in is making sure that the committee was heavily laden with faculty representation. So you'll see there that we have at least one faculty member from each school. We have 6 schools at the Health Science Center, along with others for their specific specialties. So for example, faculty that have a particular knowledge about nanoscale work, and then there's several ex officio members from administration, health and safety, and the like. I really want to underscore that and I guess I should have mentioned this earlier, I've been involved now, I just counted up, in 25 university health and safety program peer reviews. And one of the things I have noted recurrently is that there may be safety committees, but the safety committees are largely populated by non-faculty. And that's extraordinarily problematic in my opinion, because it's so important to have faculty involvement, number one, because they're subject matter experts, but, and also number two, they can help advise on how systems might be put in place that will afford safety, but also not negatively impact the core missions of the university. The Chemical Safety Committee, as it currently exists, meets 6 times a year. About 3 to 4 protocols are submitted each meeting. We'll get into detail on that in a second. But in addition to this review of protocols that are submitted, the committee is also regularly apprised of the operations within the chemical safety program. So for example, the manager of the chemical safety program, Dr. Will Bryan, who's with me here today, will report on how many lab surveys were done, what sorts of deficiencies were identified, how they're corrected, this sort of thing. And then we also include a standing agenda item on chemical waste disposal. And the reason these 2 aspects are so important is because this is one of the rare opportunities for the safety program to articulate to the faculty on the committee about all the work that goes on behind the scenes to make the chemical safety program work. So I always provide this as a recommendation to the safety programs that I review, that use this as an opportunity to educate the faculty about what work is going on behind the scenes that health and safety carries out. So what happened was the Chemical Safety Committee was convened, and there was a series of discussions, and of course this discussion about, well, what chemicals should we review, how do we go about doing this? And so they certainly recognize that we have this chemical hygiene plan in place, but we have to reach some sort of decision criteria or some cut points about these chemicals. So we'll get to what those cut points are in a second, but it's also important to understand where the catch points are within the university to find out if these reviews actually occurred. So most universities have a contracts and grants or a review and approval form, so when a research proposal goes out the door, we have a line item on that cover sheet that asks, does this work include any designated acutely toxic or dangerous chemicals? And if the answer is yes, and that's actually a web link so they can go and actually see what the listing is. If the answer is yes, contracts and grants won't let it go out the door unless the form, the protocol has been submitted. And keep in mind, it can be allowed to be pending. It doesn't have to be totally reviewed, but at least can be pending in the system. We also do a regular download of chemical purchases via our procurement system and scan for key chemicals that may be of concern to us, and that allows us to go and get with faculty and say, wait a minute, we needed a protocol for this sort of chemical. And then our regular routine lab surveillance, we have people educated to look out for certain agents, and even our waste collection folks are attuned to, if they pick up a waste that's atypical, they'll work with the chemical safety program, so we can go back and work with the faculty and say, this is a particular agent that would warrant a research protocol for this, its use. So the Chemical Safety Committee, the faculty were clear in their discussions and deliberations that risk is inherent to research and discovery. And it was interesting that what they wound up articulating was something that was, I felt, very well articulated in a report that was created after the Columbia shuttle disaster, which is referred to as the Diaz report. And what they summarized in this report was that when a decision was made to launch the space shuttle, there were 3 dimensions that needed to be managed: the time dimension, the cost dimension, and the risk dimension. And upon analysis, any person who made a decision that impacted the timeline required reviews and approvals up the food chain. And likewise, any person who made a decision that impacted the cost dimension required reviews and approvals. But what they learned was that the risk dimension was not equally managed, and over time, these risks slowly accumulated until finally the system broke. And so I think the point that the faculty were trying to make here is that, that what we want to do is we don't wish to avoid risk, we just wish to make sure that it's managed to the same degree of attention that the other dimensions are managed as well. And I think that was a really important point. It was very valuable for the faculty to be able to articulate this concern. And I believe personally, we've reached a balance between that. So how does this work? What did the Chemical Safety Committee ultimately arrive at? Well, you'll notice there it says, is the chemical agent to be used on the master list? I'm going to come back to that because really what we've got listed on the subsequent slides are the characteristics or listings of certain chemical agents that are either acutely toxic or hazardous from some other significant way. And what we found that over time, when we went through this iteration, we could create a master list of these common chemicals that are used on campus that meet one of these characteristics. So really the master list becomes almost a convenience list of these chemicals that meet these criteria. So let's just talk about those very quickly. If it's a chemical that is identified as a suspected or confirmed carcinogen, that's listed by that criteria, then it would require a protocol be submitted to the Chemical Safety Committee. If it's defined as highly toxic, as per OSHA, listed in that citation, again, it would be required to be detailed in a protocol and then submitted to the Chemical Safety Committee for review. If it's a nanomaterial, as defined by OSHA, but not permanently bound to a substrate or handled in a way that would cause aerosols to be generated, then that would be subject to review and approval. If it's defined as an explosive or a pyrophoric, and you can see the citations there as well. If it's a poison gas, an anti-neoplastic, a pesticide, or a select agent toxin, again, any of those chemical agents would require a protocol to be submitted. And so let's take some real-world examples. Let's say a faculty member back in perhaps 1993 identified that they were going to be working with urethane. Now, that's commonly used at the institution, and because it's an IR group 2A carcinogen, that would warrant that it be a protocol be submitted and reviewed and approved by the Chemical Safety Committee. And we'll talk about what the Chemical Safety Committee looks at in a second. But subsequently, we would add urethane to the convenience list, so the next faculty member who comes in, they don't have to go through this iteration. They can just look at the list and say, lo and behold, urethane does indeed warrant Chemical Safety Committee review. Dimethylmercury is not commonly used on our campus, so it wouldn't be currently on the list, but its toxicity characteristic would trigger Chemical Safety Committee protocol review, and then again, after that's completed, it would be added to the list for the convenience of the next individual. So what is it the Chemical Safety Committee wants to know when reviewing one of these applications? Well, some of these are quite obvious. What chemical agent, how much, what are the associated hazards, and where are you going to use it? We want some description of the protocol and specific manipulations to be performed. I would suggest this is what equates to a standard operating procedure, and I think there are some discussions, debates back and forth about what level of granularity is needed, but at least from our perspective, this meets the criteria that our Chemical Safety Committee has established, describing what manipulations to be performed and perhaps some other associated information. But I personally feel as though that can be done by a class of agents. It wouldn't have to be for each specific one. They also want to know what the worker training status and experience, what protective measures are in place, inclusive of the use of personal protective equipment and engineering controls. They also want to know about the waste disposal considerations, and this has been important for us that we have our environmental protection program involved in every one of these protocol reviews to make sure that we are not generating waste that we won't be able to dispose of, so we want to catch that on the front end. The committee also wants to know the outcomes of the 2 most recent lab safety inspections from EH&S if they've been in place prior to that time. The idea there is to find out how are they performing, and if there's any outstanding issues, they are to be resolved before the committee would issue approval. Now, what's happened over time, because this has been in place for about 20 years or so, that the committee, the faculty, and by the way, the faculty have 3-year lifespans, and they rotate out. Some ask to stay on, and others rotate off. But what they noted was that some chemicals were coming back over and over again. And so they felt as though some of these commonly used chemicals were triggering protocol reviews. And so what the committee jointly decided to do was maybe there's a way that we could conditionally exempt some of these chemicals, but still provide some layer of added oversight and protections. And so what we created, and I was very happy to hear about the work that's going on at the University of California right now on these 1-page safety sheets. I forgot, what was the name of those things?
SOP templates.
SOP templates. Because we've been kind of inventing independently something like this, and my hat's off to the University of California system for being so open and willing to share, so that maybe collectively we won't reinvent the wheel. But let's look at some examples of what might be conditionally exempt. So for example, acrylamide, which does have a neurotoxicity potential, but is commonly used at the institution. So the Chemical Safety Committee felt, well, if they just merely notify us of that use, and we in turn provide them, and they sign the acknowledgement for these kind of 1-page or short safety sheets, that would minimize the bureaucratic role, but still provide some level of enhanced safety. Tamoxifen is another example there. And I include this slide because I think it's a good example of the living nature of the chemical safety system, that as the program has matured, this identification of some chemicals that are so commonly used that maybe there's a different way that we can address these without adding layers of bureaucracy. So graphically, this is kind of the way I view the world, that if on the y-axis is the volume of chemicals used at the Health Science Center, and on the x-axis is increasing hazard in the degree of toxicity or hazard or whatever, that the bulk of the chemicals that are used are covered under our chemical hygiene plan, under our MSDSs and the like. And I'd say that they are adequately covered by those systems that are in place. Examples would be alcohols and buffers and the like. There's a subset of chemicals that you'll notice to the right where it says chemical safety protocol review required, like urethane, and then you've got acrylamide, which would be conditionally exempt. So, what we're really trying to, I think what the committee was trying to do was target that tail end of the distribution so that we can provide some added layer of assurance that these particularly toxic or hazardous chemicals were being handled safely without gunking up the entire system, because you can imagine if we were looking at that entire population of chemicals, it would have been overly burdensome. So I guess what people really want to know, by the way, I went to school in North Carolina, and they have a great term there called woodpeckering. And woodpeckering is when the people's head bobs back and forth in class. And I usually at this point, I think when people would stop the woodpeckering and say, well, does the system work? That's what we really want to know. You've gone through and described this whole system. Does it work? And one of the problems in working in public health and in the realm of prevention, it's sometimes hard to tell directly whether the system works. But I can tell you, if it wasn't working, here's what we would have. We would certainly have faculty complaints about unnecessary burdens associated with the process. We would have injuries and property damage associated with chemical accidents. We would have worker safety complaints not only to us, but perhaps to regulatory agencies. And we would have regulatory noncompliance upon inspection. So I can tell you that thankfully to date, we have not experienced any of these untoward effects. What we do know for certain is the process provides a level of institutional assurance regarding the safe use of particularly toxic and hazardous chemicals for the protection of all parties involved. So now I want to switch gears because this really ties into an overarching issue, which is this issue of safety culture. I'm seeing a note. Would you, if you would like to ask a question, please. Oh, that people will submit a question. Okay, great. All right. So the safety culture, a lot of people banter this term around, but not really sure if we've reached concurrence on what it means. It's the attitudes and beliefs and perceptions shared by natural groups as defining norms and values which determine how they act and react in relation to risk and risk control. Culture is a noun, but it's inextricably linked to behavior, which is a verb. So we really can't measure culture directly, but behavior can be measured. And behavior, good or poor, can be an indicator of culture. That's a long way of saying that safety culture, at least in my opinion, is how people behave when no one's looking. And so that's what we're really trying to drill down to, is to figure out how we can collectively improve the culture of safety across our respective institutions. Now, some of you are familiar with the U.S. Chemical Safety Board's interest in this area, where they, after several unfortunate events, focused their attentions on 125 laboratory accidents at research universities. And they came away with this notion that there seemed to be opportunities for improvement for safety culture in the university setting. And I really resonated to a comment that's on one of the videos from Professor Andrew Hopkins, who mentioned that if you took its safety group and sent them into an airline industry, they would focus their attentions on where most injuries are reported, which would be the baggage handlers. And that would be very appropriate because that's one of the roles of health and safety. But by addressing the issues for baggage handler injuries, in no way provides assurance that the plane won't wreck. And the only way you provide assurance for planes not wrecking is by having everyone within the system being focused on safety and making decisions at the local level that are ethical and appropriate. And this is particularly important in high-risk and complex settings. So that's what we're really trying to get at. This notion of elevating safety culture is something far outside the purview of a standard EH&S department. It has to be embodied and reflected by every individual. So EH&S cannot do it alone. While EH&S programs are necessary, and they certainly can provide assistance and provide guidance, a true culture of safety requires a commitment across the organization with a particular emphasis on the faculty, because if you think about it, that's why the students are there. The students are paying tuition to learn from the faculty, both directly and indirectly, and so that they have to serve as role models in that regard. I think that it's important for EH&S to function in a service role and be perceived as providing a collegial and valuable service to all members of the community, the faculty, staff, and the students. Now, there's an important cautionary note when you get into the discussion about safety culture and safety climate, is that in situations where there are powerful subcultures within organizations, that can be problematic when one is trying to undertake these changes. And this third bullet that mentioned by Pigeon, therefore, it is questionable whether a culture of change program can be designed for a large organization without taking into account the subcultures that are in place. And when I first read this, I thought, boy, he has defined universities perfectly, because there might be a lot of organizational commitment, but if that commitment is in place within the subcultures, that can be very problematic. We've been involved in a pilot work. Janet Gutierrez, one of our colleagues here, for her dissertation, actually undertook a pilot project to measure safety climate in 5 test universities. And I'll show you the data here that, well, I don't have the slide, but what was interesting was the results of her survey, our pilot survey, indicated exactly that although people felt institutionally there were systems in place to promote safety, it was at that local level where there was this disconnect that was occurring. So that's why it's so important that we make sure this is infused throughout the organization. Certainly the issue of safety is of paramount importance because we have an ethical obligation to protect all of our constituencies that are present. And it's critically important that we preserve the public's trust in our endeavors. I think at least the successful pitch that I've had with faculty here at the university when there are some issues is that I try to remind them that not a single dollar is given to our institutions without a set of both explicit and implicit expectations. Explicitly, the funds are to do a certain work or activity. So for example, let's say we're doing breast cancer research, those funds are awarded to do breast cancer research. But implicit to that award is that the work would be done ethically, be done compliantly, and be done safely. And I see my role is to help the faculty achieve these implicit requirements so they can do the explicit work. And so that's why I think a safety program has to be service-oriented in that regard. Now, Cotter has laid out an interesting 8-stage step for creating process change. And I thought this was interesting when I thought about the events that have unfolded with the Chemical Safety Board and others. So in order to change a process, first we have to establish a sense of urgency. And I believe the U.S. Chemical Safety Board has done that for us. I think with their findings, they have shined a beacon on some issues that are inherent to universities. So I think the sense of urgency has been established. A guiding coalition, I think, and a vision and strategy are being developed by several parties across the country. And I would applaud the University of California and all of its component institutions for the work that it's undertaken to help lay out this vision and strategy. And likewise, the American Chemical Society, as some work is becoming to the surface that I think will help us there. But then we've got to communicate that change vision. And sometimes change isn't easy, and so that's going to be a bit problematic. But I think there are some things, some short-term wins that can be taken. And one of these, I would argue, is this Chemical Safety Committee tiered review approach. And then we want to consolidate those gains to produce more change and then anchor this in our new culture. So I would encourage each of you to think about where you might be along this 8-stage process for creating this change. It's important to understand that any cultural change will not occur overnight. There's an interesting study published in 2009 where it was a public utility that was trying to change its safety culture, and by their own admission, it took 9 years to fully implement. So we shouldn't get frustrated if it doesn't occur instantaneously. It's going to take some time, but I think it's not an engineering solution, it's an organizational solution. So we have to acknowledge that and understand that it's going to take a little back and forth in order for it to occur. So what are some short-term wins? I guess if someone were to ask me, Bob, what do you think we ought to do? Well, I think it's important that we formally communicate to the campus from a high level that we're committed to safety, whether that's through correspondence from the president or the chancellor or however that occurred. But there should be something in writing, whether through a policy or through a communication, it doesn't really matter, but somehow articulate that we are committed to safety, everyone that's present on this campus. I think that we should look internally at the EH&S program and ask ourselves, do we have a chemical hygiene plan in place? Critically important, does that chemical hygiene plan also address physical hazards? And this is an oversight identified by the Chemical Safety Board that discovered that many chemical hygiene plans, probably unfortunate labeling, I suppose, but many chemical hygiene plans were focused on the health-related or potential health-related aspects and sometimes completely overlooking the physical aspects or hazards of the chemical agents. So let's make sure the chemical hygiene plan addresses both of these. We'd like to know, do the necessary institutional policies and procedures exist? Critically important, does a routine safety surveillance program exist? And notice I did not use the word inspection. What I meant here is a collegial way that safety goes out and checks on things, but works with the faculty or whoever to correct these issues. It's not meant to write tickets. It's meant, research is a dynamic activity, so things are going to change. But if we go out in a collegial way and check to make sure things are in place and then help correct any deficiencies, that will get us a long way down the road. Do we have good relations with the faculty? And an interesting question. Does the safety program understand the mission of the institution and its function to provide a service role? And in some of these peer reviews I've done, sometimes I don't think the safety program understood that they were supposed to function in a service role. Then I think another short-term win would be for institutions to think about creating some mechanism for reviewing high-risk chemical use. Again, universities are familiar with committees because they've been living with radiation and biosafety committees, but sometimes the chemical stuff is overlooked. If you're going to go this route of creating a committee, I cannot emphasize enough that the membership should be largely faculty, because that's critically important for joint governance and buy-in. Then they have to reach some sort of consensus on what chemicals and what amounts would require protocol submission, and make sure that you're considering both the safety and health hazards, not just one or the other. I would argue that there's opportunity for guidance, maybe in the form of listings or characteristics from the American Chemical Society, or maybe consensus documents could be created so that we don't have a bunch of people reinventing the wheel, but philosophically you can see at least the approach that we've taken here. Another important function would be for safety to go out and do these routine lab inspections, and then you would find if there's any deficiencies and assist the principal investigator in fixing those things and track them to completion. An interesting item that we've done here is that on our standard lab assessment checklist, we've added a simple inquiry as the last item, and it just asks the lab personnel, do you have any safety or security concerns? And it's fascinating when you ask that question. We collected the data, and when we asked that question, 88% of the time the individual did communicate a concern, and 80% of those times it was not on the list. It was things that they identified that were outside the traditional purview. For example, I'm concerned about the water in the water fountain out in the hall. I'm concerned about the lighting in the parking garage. Now, maybe these things are a little bit outside the purview of health and safety or traditionally, but it's a wonderful way to engage individuals and then to connect the dots and get the right people to correct those problems. So I really encourage you to ask that question. I also want to make sure that we have a means for reporting events and near misses, and so we can do this in a variety of ways, but I think it really, in our case, we have people who openly call us, and I think that's great, that people will call up and say, hey, I've got a concern. That's great, we respond to it, but having that open channel of communication is critically important. So, at the end of the day, chemicals are essential to research, and we have these baseline chemical safety controls that are in existence, but I think most people would agree that some additional level of attention and oversight for a subset of these chemicals that are particularly toxic or dangerous is probably a prudent thing to do. The trick, I guess, is reaching consensus on the decision points. That's both a science and an art, because I think it's reflective of the local organizational culture, and that's why the faculty involvement is so important. We're happy to share our list, and we can show our characteristics, and we've done so here. And your list may vary, but I think it's important that you go through the process. And I think we have to underscore that risk is inherent to research. We just need a consensus way to manage it. And I think to do that, we have to have a researcher and faculty buy-in in order to achieve that goal. So with that, I welcome the opportunity to speak with you today. And I don't know exactly how the process will work, but things will email in or perhaps.
You're right. Do we have any questions from the audience?
Yeah, we have about 3 questions, and I encourage others to go ahead and type those questions in. In the meantime, before I get to the first question, again, I just want to thank Dr. Emery for providing this. And I think, some of the things he talked about is some of the easy wins and how do we start changing the culture. And our goal is actually with these webinars is to do exactly that, is to provide a tool not only for EH&S, but more importantly for faculty to kind of be able to hear this message. And for the University of California, we're using these webinars as a tool for our chemistry chairs, biochemistry, or any type of laboratory chair, so that they can share this information and make it available. So the more that whether it's not just the University of California, but if there's other institutions that feel that they have some information or a presentation that would be vital for the community in which we work in when it comes to laboratory safety, please contact myself or Ken Smith. I believe my information was sent out with the registration, but we do certainly encourage that. So with that, we have more questions coming in, but I'll ask the first question for you, Dr. Emery. It asks, how do you define suspected carcinogens? Anything on the IARC 2A or 2B list? Is a question from Tracy Glens.
Yeah, it's actually, I have my colleague Will Bryant here, and it's the definition is 1A.
1A or 2A.
Yeah, so the definition, and we have this codified in a flow chart that we're going to share with Ken, and we're happy to share with whoever, but we have these definitions codified. So if it's a 1A or 2A carcinogen is listed as IR, then it would kick into the protocol review process. And I guess I do want to underscore, just because it goes for protocol review doesn't mean you can't use it. All we're really asking is saying, how are you going to use it safely? You know, have you considered how you're going to use it, and if something goes wrong, what are you going to do? That's all. It's not the death knell. It's just we feel that these particular agents warrant some reflection, and we'd like to document and reach some concurrence on how they will be handled safely.
Great. Thank you. Okay, next question is from Benjamin Smith. If a laboratory plans to work with a biological toxin or hazardous chemical that has an antidote in the event of an exposure, does your chemical safety committee require the PI to have the antidote on hand?
I can speak from my experience. We did have one individual that they were working with a chemical agent that did have the antidote, and it was the committee just agreed that that was on hand. Is that still the case?
Yes. If there are any antidotes available for that specific chemical, then yes, we would require the researchers to have that on hand.
And I guess I should have included that here at the Health Science Center, we're a little bit, I started out in health and safety, and I fell asleep in a meeting and woke up and inherited risk management, insurance, and employee health. And so one of the things we've done is made sure that employee health is a representation is present on each one of those safety committees. And one of the reasons is exactly this issue, that if there's, on the case of the Chemical Safety Committee, if there's an agent to be worked with and there's an antidote that may be present and available, obviously there's considerations about its cost, its storage, its use, and this sort of thing. And so we have employee health as a member.
Great. Thank you. Third question here is from Tom Opal. Are the chemicals of concern self-identified or automated by link to a database? Is this database tied only to the grant application, or do you have central purchasing controls? And then finally, any tips for a campus that has no central purchasing or all-encompassing grant database?
Yeah, so all of the information on the chemicals, both that master convenience list and then the criteria, is on our website, but unfortunately it's not automated to this point. What we would love to get to, and actually Ken and we were talking this morning, from our end, if in a dream world, it would be nice if we could reach some level of consensus on what these cut points were, so that the faculty could perhaps enter a CAS number or something like this, and it would, would kick it out and let you know exactly why is it being kicked into this bin. So it is not automated.
So right now, though, we are working on a program that would actually, take say a chemical inventory and take our master list and search through that chemical inventory for that lab, and then let us know if that researcher has chemicals that need to go for protocol review.
Yeah, one of the interesting things I see as I'm learning more about how the University of Texas is addressing this in this situation is that your list of identified chemicals and what UC refers to as the Exhibit 1 list of chemicals from our settlement agreement, that there is more commonality among those lists among what thresholds, the thresholds that you either derived or the thresholds that were given to us to establish that higher level of review. And what's interesting here is that you have successfully brought it from them applying in kind of the use authorization or developing their SOP and actually having a committee peer review and approve it, versus in our case, our settlement is asking that the PI just simply perform that review. And so I think, that is very interesting from my point of perspective to see that, a very similar system is in place and functioning and working, even with a peer review.
And I will mention, I've shared with Ken, one of the things we do here operationally is once a year we pick one of the areas within health and safety and do a customer service evaluation. And a couple of years ago, we actually did a survey of faculty who have active chemical safety committee protocols. And we asked, how did the process work? Was it over-encompassing, this sort of thing? And the results were very positive because Will and his team actually helped the faculty complete the forms and can anticipate some of the issues and questions. And so I think it's done in a very collegial way, and we have the data to show that at least the faculty who responded to the survey seem to agree with that.
And one final thing before I go to the next question, we have been working with our suppliers and procurement to basically have certain of these items flagged. We've addressed it with our procurement department. They said that can be done where an email would be sent upon the purchase to indicate that an SOP or some other type of controls would be required. We're at the beginning stages of it, but we do know that it's possible, and we can capture probably 95% of the substances that are on our Exhibit 1 list.
If I may, real quickly, another important part to this is to have a highly educated and attuned environmental group, the people who are collecting the waste, because research is dynamic and stuff can come in from a variety of ways. And so from time to time, we've had situations where the guys who were collecting waste identified something that, hey, this is a bit unusual. This is, and then they'll work with Will and his team and find out that lo and behold, some other chemical was brought in by some other means. And it's that's when we go back and work with the folks to get it all resolved. So, having these multiple points of capture, both at the front end on the contracts and grants end, but on the tail end, on the waste disposal end, just given the inherent dynamic nature of universities, that multiple approach seems to be important.
It's also a good way for to develop ideas about waste minimization. Researchers are always looking for ways to minimize their waste and minimize the costs.
Mm-hmm.
Okay. And then we do have two questions that are similar. Can we get a copy of the slides from today, and will they be available online? And yes, we will. The session is being recorded, and once it's, we'll send it out to all the participants, the link to the recording, and we'll also, believe, put it up on YouTube, and the link will be up on the Center for Laboratory Safety, and then I believe we'll also be able to put some of the slides up as well as part of that.
Yeah, and we'd be happy to provide the web link. We'll get Ken or whatever your central catch point would be, where it'd be best served, but we'll be happy to put our web link out there to the chemical safety program so people can actually see the protocol submission process and the decision tree and, or the flow chart, and we would welcome people's comments, because we certainly think that it would benefit all universities and research environments if we reach some sort of consensus on this approach.
Absolutely. And so we'll definitely make that available as we move forward. So next question is from Robert Ott. The question is, how was a sense of urgency created within University Tech Houston Health Centers?
Well, that's interesting. Without airing too much dirty laundry, I was astonished to find, this was back in 1993, that we had a faculty member that was working with a highly explosive material, and there were absolutely no controls in place whatsoever. And so at that point, I almost fell out of my chair, and I'm like, wait a minute, this is crazy. That I came from the health physics world where everything is traced down to the atom, and to think that someone could actually just buy stuff. Of course, remember this was pre 9/11 too, so but that someone could just pick up the phone and buy this material. I think that really caused a sense of urgency. We sat down and said, look, this biohazard committee, by the way, back in 1993 would have been the catch point, and even they admitted, wait a minute, this is outside our league. We need to. So that's what I think was the wake-up call for us.
Great. Next question is, how important is to have a chemical inventory list on site versus a hazard class type?
Probably at the end of the day, there seems to be this obsession over having a detailed chemical inventory in general. But I guess my response is often, well, what do you need it for? I mean, do you need it for operational activities? If you need it for the fire department, I see chemical inventories that are far too granular. That's where you get into hazard types. That's what I think is most useful there, and I welcome the comments of others here. But it just makes good business sense to manage your inventory so that you're not wasting materials and the like. But I've experienced some situations where, in my opinion, it's far too granular. Will you deal with it day to day? I don't know if you have.
Yeah, I think chemical inventories are invaluable. I mean, I don't see how researchers can manage without chemical inventories.
And by the way, Will's a chemist, so he's not picking on others.
Yeah, I think that having a chemical inventory, that's an easy sell.
The next question, and I think, as I know, discussion that Ken Smith and I have had for some time, deals with one item missing from the discussion, is the reaction hazards. This includes issues of scale-up, chemical interactions, byproducts, etc. Please comment.
Interesting point. That I think that leads to this issue of the dynamic nature of research and where routine surveillance comes in. I will tell you that we have not an annual, but an update requirement that these protocols are reviewed, and that's, forgive me, the ink's going to flake off my diploma because I don't remember how often do we do it, 3 years?
No, every year.
Every year. And what they get is a very simple form that asks, has anything changed? And, are the workers or, so we do have a mechanism to reach out to the faculty to find out if anything has changed, and then we have this routine surveillance piece. But I think the question is good. I mean, we have to understand research is dynamic and things will change, and maybe that's something that we should put on our protocol form, is ask about, do they anticipate any changes addressing particular this issue? Will this work ultimately result in some sort of ramp up or other mixtures or something? That's an interesting point.
Yeah, and it's interesting, and this is Ken, if I could jump in here, one of the things that is we're kind of cross-comparing notes on our approaches and looking for similarities is it appears that you guys in the University of Texas here has established a series of criteria or thresholds that are based upon the characteristics or the properties of the material. And, you know, it seemed like a next logical step to, you know, for refinement of this method, to not only add the criteria, but also some other quantity or physical attribute about the experiment. For instance, the quantity manipulated or the maximum temperature reached, to kind of help delineate. Now, you guys addressed that in that when they trip the property trigger, they're working with a highly toxic gas, that you address those questions in your application as part of the procedure and details for it. But you know, if part of our approach was to maybe more narrowly define which materials trip this higher level of review, we can put some quantity threshold or some criteria in there. So that thought has not escaped our minds.
Yeah, the notion of applying physical pressures or temperatures or something like that is something that needs to be considered. But you're absolutely right. Our catch point up front is whether it fits in these several bins.
So a couple more questions, and I think I'll try to tie these two together. It says, first question is, what is the typical composition of your safety council, which I think you said faculty, and the other question that's related is, how do you entice overwhelmed faculty to serve on your committee?
Okay, well, let's see. First of all, the safety council consists of, it's appointed by the president, and it consists of the chairs of those, the specialty committees, so radiation, chemical, biosafety committee. It also has then other faculty representation from the schools, and then it has some ex officio members and some administrative folks. So for example, the head of facilities is on there, the head of the animal care is on there, a representative from the University of Texas Police is on there. And to be quite honest, that group rarely makes many hardcore decisions that impact research, and by that I mean those issues are grappled with and resolved at the specialty level. In other words, if it's a radiation safety issue, it's typically resolved with the Radiation Safety Committee, and the chair just merely informs the Safety Council. I'll tell you one out of the inbox. There's an issue with eye exposure for radiation. That's an issue that's being resolved within the Radiation Safety Committee, and they would just merely inform the Safety Council that it's being covered. That's really what's going on there. How do we entice the faculty to participate? I've been in this business 30 years, and the 3 desirable criteria for committee service is it meets less than an hour once a month, that there's no homework assignment, that all the stuff is organized and brought together, and they just merely are asked to exercise their judgment, and they're fed. And those 3 universal criteria seem to work pretty well, because if you can get the senior faculty on there, then most of the battle is won, because they in turn can go and talk to the recalcitrant ones and say, look, pal, these guys aren't evil, they're not bad, they're just trying to do the right thing. I can do it, you can do it too.
And related, how do you measure the success of a committee?
Well, a couple of ways. One is we certainly can look at injury rates, and those are all low, injury rates very low, compliance and that sort of stuff. But another success measure or metric that I use is number of protocols rejected, and the number is 0. Now, one could argue, wow, that's indicative of a rubber stamp committee. But I would argue that it's indicative of preparation of the protocols that are finally polished before they get there. So it's really establishing a level of trust. So we just don't blindly send a form to a faculty member. We'll sit down with the faculty and say, we can fill out this demographic stuff. Let me kind of help you get this part filled out. But when Will reviews it, if there's any bumps in the road, he'll work with the faculty well before it ever gets to the Chemical Safety Committee. So I would suggest that it's because the protocols are polished and the issues are resolved prior to its arrival to the respective committee, that one indicator of success is that the protocols are approved and that we have not gunked up getting any grants. We also have mechanisms in place so that provisional approval can be provided so that the grants can get out the door. So, for example, I know you find it's hard to believe, but the faculty member is very busy and something's last minute, they can put the materials together and can review it and say, okay, well, there's still some more work needs to be done, but in general, we can provide provisional approval, so at least it can go on in the process, and then we can work on it behind the scenes to get it resolved.
Okay. And another question here came in. It's Dr. Emery, in developing your list, is the route of entry taken into account? For example, many toxic chemicals are on the list because they are toxic by ingestion only, but people in labs don't eat their chemicals or would have a hard time accidentally ingesting a significant amount of chemical through incidental contact.
So in that case, what we want to do is just provide assurance that good lab practice in place, PPEs in place. It's going to be pretty simple. If they go to the website and look at the forms, they're not that long. What I see in my safety career, sometimes questions are asked on these forms that appear to be for academic interest rather than what is the bare minimum stuff we want to know. And so it's what is it, 2-3 pages long?
Yeah,
2 pages long. But that combined with the routine lab surveillance to see some evidence of good hygienic practices in place should take care of that.
Great. And we just have about 5 more questions here. It kind of relates to the last one, but it said, is sponsorship by the president required for a safety committee to function properly, and what and how does his sponsorship of the committee, okay, it's this type here, and what and how does this sponsorship of the committee relate to a quality safety culture?
Well, I personally believe that by the president endorsing the existence of the safety committee communicates his or her commitment to safety. And the appointments, although we provide the recommendations, the appointment letters come from the president. And I think that sends a powerful message to the faculty that, we are committed to safety and your role is important. And it's actually interesting, a new mandate that we have is that the president has wished for us to track the numbers of protocols reviewed by each committee member. And the reason being is apparently what happens is some people will get on committees but don't do anything. And so he wants to make sure that junior faculty are involved. So he wants a mix of senior and junior faculty, but he also wants to make sure that the workload is shared so that you don't have some people who are passively sitting there and eating, getting free lunch, and and not reviewing. We had an interesting side note, especially in the biosafety committee, some of the faculty really enjoy being on there because it's an easy way for them to stay abreast of research, of developments of research as they review these sorts of things. And did I answer both parts? I think I've got the other part of the question.
Yeah, I think that was, yeah, you did there. Again, just a couple more. Advice for how to get contracts and grants to make the requirement that yours did 20 years ago.
So probably, I'm going to, just based on my 25 peer reviews, most contracts and grants things have a cover sheet or what we call the review and approval form. And that's a variety of things, the conflict of interest thing in place and, all that kind of. And so we have 3 lines on that. And one of them is it radioactive materials? Is it potentially infectious agents? And that dead ends in a hot link so you can link and get the definition. So it asks, does it involve source of radiation, potentially infectious materials, and then designated acutely toxic or hazardous chemicals. And that's the 3 ones there. And we met with them. I actually ran contracts and grants for a while, so I have them pretty well schooled on what that means and what it does not mean. And then they know to just call us, and they know we're not going to gunk up the work, that we're going to work with them to make sure that the process keeps moving along.
Okay. This is somewhat a little bit longer one. A couple details here. It says, how often are the approved protocols reviewed, and are laboratories approved for chemical use? Are laboratories approved for chemical use or the occupants, i.e., if a PI is approved to use MPTP, for example, do you also approve the laboratory staff and graduate students who use the compound on the protocol? If so, how do you handle new employees?
Okay, so first of all, the protocols are renewed annually, but that renewal is a very simple 1-page thing, just checking if anything has changed. But on that is inclusive of any new staff, any updating of that. So several catch points because people come and go. On the initial protocol that's submitted, the faculty member, so that protocol is really approving both the PI and the laboratory and the people who are in there. So it's kind of the whole thing together. So they would list what room you're going to work in and what people are going to work in there. And then we have their training and documentation and PPE and all that kind of stuff. Then the onus is on them to notify us of any changes. And then annually we do that check, the renewal. But in addition, we also check for this when we do our routine surveillance. As we go in we're looking at, here's your protocol saying you got Mary and Jane and Susie. Oh, by the way, Susie's gone now, so take that one off, and here's a new person. Oh, they don't have training. Okay, let's get them connected. And so it's that multiple catch layer.
Great. And just a couple more. What percentage of the faculty using hazardous chemicals are tenured or tenure track?
Well, we don't record that data. I'm going to guess geez, I don't know, 30%. I don't know.
I couldn't even guess.
Yeah, I couldn't even answer the question. What percent of our faculty at the university are? I think we have last time about 1,600 faculty, I believe. And what percent of those are tenured, tenure track? I really don't know.
Okay, great. And looks like this might be the last one, unless we get more in. Does every individual chemical in that list require a protocol, or can a protocol include multiple chemicals?
Yeah. Occasionally, yeah, we'll have a protocol with, if a researcher is using several hazardous chemicals, we'll just combine them on that one protocol. We'll have the procedures for each individual chemical, but they'll just be combined in that one protocol so that the researcher only has to get approval once for that chemical.
And just for my own application, would they have common characteristics, or these would be very widely dispersed?
No, they could be different.
Okay.
Yeah,
Okay.
but we'll address
Each
experiment, each hazard, and if there's any additional SOPs that need to be written, we'll take that into consideration as well.
Right.
Okay. And that is all the questions we do have. I do have a couple people that have raised their hand during the presentation. Unfortunately, we're not going to open up the mics, but if you do have a question, we have about 3 more minutes until the slated close of this webinar. Feel free to type your question using the question tab on the GoToWebinar material, and we'll move forward with that. And one of the things that as we talk about the university or research community, especially when it comes to safety, with all the different things that have happened in the last several years, both at Texas Tech and at UCLA, obviously there's increased attention, and the Chemical Safety Board is obviously putting a lot more attention on a lot of these areas. And having attended the ACS meeting in Philadelphia recently, and then now with the UC Center for Laboratory Safety, really I think what the goal is that if we can create that research community from a safety standpoint and have that central repository to be able to share information like we're doing today with this webinar, the SOP library at the Center for Lab Safety, as well as any other material, as we make advances in this area, I think all of our goals are to make the researcher's life easy. We don't want to hinder research, and that's really what our goal is in doing this, is really trying to find the most efficient way that we can mitigate risk for the researchers as we move forward, and not to hinder it and slow down progress in advances that can be made. With that, I don't see any more questions, so Ken, I will turn it back over to you for the closing, and then we'll wrap up the webinar.
Yeah, well, again, Bob, I would like to thank you very much for the presentation here today. As always, anytime you talk, I find it very informative, and clearly I think there's a lot that the University of California can learn from your talk here. Again, I'd like to thank the sponsors again of this, both the UC Center for Laboratory Safety and the University of Texas Health Sciences Houston here for it. And last but not least, just a reminder that the upcoming webinar here will be next week on a Wednesday. Excuse me here, I got both dates up there. It's going to be on the 13th. It is going to be noon to 1 Pacific time, and because you attended this class here, or this webinar here, we will send out the invite to your email that you subscribe to at this one. So with that, Bob, thank you very much.
My pleasure. Thanks.
All right, thank you all.